getting old.
How old are you?
Not old enough to say he's getting old.
How old are you?
24? How old are you?
I'm about to be 19, which is why I can say that you're not 44, brother.
24.
98.
I still can't say you're 24. I know
So
somebody
what are you
who's
trying to
20
solve for though?
Nice, man.
X.
So
So
them
you need to get rid of what's around the X.
Anyway, besides.
Does that make sense?
You look
Alright,
like
if I can grab everyone's attention, I know that some of us are still working on some details of number 6, but I want to talk more about number 5 overall, because this is going to help us understand things, and then we'll touch on a couple of ideas with number 6. So, writing and solving an inequality that models this situation.
sleepy.
One of the things that I want to point out really quickly is I saw everyone write this inequality pretty well, and when I started pushing on ideas, most of us could explain pretty well that, sorry, I'm trying to get this written, that the 250 was only happening one time, but we were repeatedly what with this $1.50? Adding, right? That's why it's being multiplied by b. So here's what we always want to keep in mind though, and make sure that you note this to yourself. What does this thing mean? Like, that's a pretty big expression. It's not just a single number. What does that expression mean?
The delivery.
There is a delivery fee, yep. But like, what are we adding up? Like, what is this whole thing? Okay, what about Val's veggies though?
Charges $2.50 for delivery.
It's $1.50 per bag.
Okay, it's $1.50 per bag,
What she said about the delivery.
about the delivery fee. So for B bags of lettuce, notice how I'm intentionally using that variable. This is the what for B bags of lettuce. This is how much it would.
For one bag of lettuce.
No, that's B bags of lettuce. That's how much it's going to
Cost.
cost for B bags of lettuce from Val. It's important to keep in mind the context, right? What is this expression meaning? It's the cost to purchase from Val. Whereas this expression is what?
Cost for salads.
Okay, the bags of lettuce, right? So that's what's going to help us understand this inequality a little bit better. I think most of us got there. Braden, I think it was in your group, I may be wrong on this, but we talked about whether it should be less than or equal to. Is that right? Was that in your group?
Yeah.
Okay, so why did y'all end up deciding less than instead of the less than or equal to?
Because it says, the question asks, for how many bags of lettuce must be purchased for Val's veggies to be cheaper.
If it's cheaper, right, that's that, again, that context idea. Could it be less than or equal to, or does it just have to be less than? Just less than. It's called a strict inequality. It has to be less than. All right. Now, most of us are pretty good on solving. Again, the first step, and I think, actually there's multiple steps we could take first, but one thing we can do is we can subtract 150b. Do that with a like term over here, because what is 1.5b minus 1.5b? 1. 0. Okay?
You agreed with me.
And then I thought about it for half a second. Okay, so remember, what's the relationship between addition and subtraction? They are inverses, creating the identity 0. So why did I subtract by 1.5b on the right hand side?
Which is one side and the other.
Why do we have to do it to the other?
To make it true. Yeah.
Let's work on that language a little bit.
He said booyah next when he said that.
What is true about the orange inequality and the black inequality? There's an important E word.
Equivalent.
They are equivalent. Do they look the same?
No.
No. Do they have the same solution values? Or a set of solutions?
Yes.
Yes. Because I subtracted from both sides of the inequality, I maintained the equivalency of that inequality.
Oh, wow.
You kept it making it true.
I kept it so that the same numbers that would make the orange inequality true also make the black inequality true. That's the point, is that I want to stay equivalent. I wanted to maintain the same solutions. Similarly, when I subtract 100 here, what's 100 minus 100?
0.
0. To maintain equivalency, to keep the same solutions, I have to do it on the left-hand side as well. So 150 is less than 2.5 B. Last step to solve for B.
Divided by 2.50.
Okay. Now this is where we run into some issues, or some of us ran into some issues, and we need to pay attention. We are super used to the inequality being flipped, and so I saw several of us try to say that the solutions should be from 0 to 60. Do not forget though, think about a number line. Obviously the number 60 would need to be on this number line for the solutions. But which direction I shade means that I should be shading the what for the inequality. I always shade the solutions, right? The whole point is get the solutions. If I shade 50, is 60 less than 50?
No.
No, right? So I would not be shading to the left. Is 60 less than 70? So we're shading to the right. So we want to pay attention to making sure we get those inequalities. Overall, we did a great job describing in words and working with that interval and set notation. Did you see any issues with set and interval notation?
I did not.
Okay, I didn't either, so we're going to skip over that for now. Tomorrow we're going to start 4.6, but for homework, 4.5, set number 13, go numbers 23 and 24. This will be for an accuracy check, so you need to get it done. We will have the video up from when we went over homework today on YouTube, so you can get help there if you need help doing the homework. Yep. We'll give McKay below his nose. It was lovely.
Is that actually going to be on it?
I mean, yeah, it was already recording. I'm not cutting it out.